Alright, in this video we're going to continue Chapter 5, Section 1. We're dealing with graphing quadratic functions. Alright, I want you guys to make an x-axis and a y-axis. And right now, to the best of your ability, I simply want you to put a point right here, which is going to represent our vertex. Go ahead. That's going to be our minimum. I want you guys, to the best of your ability, to draw a line of symmetry, the axis of symmetry that's going to pass through this. Alright? I'm going to make a line of symmetry first, going through the vertex. And I want you guys to sketch this and try to make it as balanced as you can on both sides. I don't realize it's kind of tough to make this perfect. Alright, so there you go. There's our parabola. Okay? And once again, you guys have already labeled this. That's our axis of symmetry. And the axis of symmetry will always, always, always pass through this vertex. In this particular case, it's a minimum. Okay? But there's a special formula that gives you the axis of symmetry every single time. Does anybody know that formula from a long time ago? The formula is this. Negative b over 2 times a. Now this formula only works if you have a quadratic equation or a quadratic function in this form. Ready? Right? Y equals ax squared plus bx plus c. We have 3 terms, everybody. We have this leading term. We have a middle term. We have a term here at the end. Oops. Okay. The ax squared, where this x is being squared, that is what's referred to as your quadratic term. This term in the middle is what's referred to as your linear term. And this is the easiest one. The number right there at the end is what's referred to as the constant. By the way, in a quadratic function, the constant right here at the end will always be your y-intercept if it's in this form. Okay? That constant at the end. So think of your y-intercept as being 0, comma, whatever that number is, whatever that c value is, that will be your y-intercept every single time, if it's in this form. Okay? So, Peyton, do you have the formula that we had for that parabola? Ours was what? Negative 16 x squared?
Yeah. Plus 102.6.
Plus 7? Yeah. Right? Okay, so this was our formula, okay? So by the way, guys, if I said, hey, what's your a value here? What's our a value in this particular? Negative 16. What's our b value? 102 point, I'll put 6 repeating, right? And our c value is a 7. So we have a, we have b, we have c. I wanted to use our formula to find the axis of symmetry. By the way, this formula right here, if I put a star next to it, this is a formula right here that you need to have in your journal. You're going to need this. You're going to use this a lot. Okay? If you ever take the TSI, okay, the Texas Success Initiative going into like a junior college, all right, this formula you will use to solve a projectile problem. If you're taking the SAT and you're doing a non-calculator portion of the test, you will use that formula. Okay? So, if I say negative b, what is our b value? 102.6 repeating over 2 times our a value, which is negative 16. What I want you to do in the calculator is we're going to do this right now together. We're going to calculate that together. Going to hit second quit. I'm going to hit alpha y equals enter to give me my little fraction marks. Okay? So alpha y equals enter. I'm going to type in negative 102.6. I'm going to add a few. Then I'm going to say 2 times negative 32. Now, when I press enter, it'll probably give me some fraction, but it might be in this one. Oh, I messed up. What did I mess up?
Where did you get 32?
You're right. I need to change that to. I was thinking about what 2 times negative 16 was.
Yeah.
Sorry. I was kind of calculating things in my head. There we go. Sometimes I have a problem. I tend to do things a step ahead. You guys see this number right here? 3.2083. Has that come up anywhere else before? Yes. Should be X to the maximum. Was it? To the second. Let's go here. Check this out. Hey, look. See that maximum right there? 3.208. That's the same number that we got right here. Now, the next thing I want you to do in the calculator with me, see if this will make sense to you as I do it. Ready? Negative 16. Type in negative 16. Open up a parentheses. Scroll up. Grab that. Close it and square it. Plus 102. Add a few sixes. Open up a parentheses. Grab that. Close it. Plus 7. Now, I typed a whole bunch in right there. And I'm going to go back and explain to you what I just did in the calculator. What I did in the calculator is I took our equation and what did I replace the value of x with? I replaced it with that 3.2083 that we repeated. And this right here represented, like you said, Peyton, that represented the amount of seconds. And why did I plug that in here and in here? Because what was I trying to solve for? I was trying to solve for the maximum height at this amount of seconds. And what did it come out to? 171.69 feet. So what I'm trying to tell you is this. If you haven't picked up what I'm putting down, if you're not spelling what I'm stepping in, if you're not hitting what I'm pitching, what I'm trying to tell you is you can take our original formula, find our axis of symmetry, all right? Remember, this is where x is equal to this. That's the line that passes through it. Take a picture. This is the line that passes through the vertex, which in this problem goes right through there. And you can find your maximum height without having to do all of the graphing functions of the calculator. You can simply use x equals negative b over 2a, and then whatever you get for that answer, what are you going to do? You're going to take whatever you get for this answer and do what with it? Plug it in. If you plug it in, that gives you your maximum height. Okay? So, I want you guys, when you guys do this, understand you don't have to use all of the graphing elements of the calculator. You can simply use what formula? X equals negative b over 2a, and whatever number you get for this, plug it into your original formula, and that will give you your maximum height every single time. Okay? All right, let's look at problem number 1 here. Zoom in. All right, before we do problem number 1, here's our equation. What do you guys think A, B, and C are? In this equation? Yep. Good. Oh, A is just 1. It's just a number that's in front of the x squared. That's a 1. Negative A, 15. Very good. Okay? What equation could I tell you that you guys need to use to find the axis of symmetry? What is that equal to? Negative what? Negative b over. All right. What is, if b, it says negative b and b is negative a, what does that mean? What's negative of a negative? Positive. So I'm going to over 2 times a. What was our a value? Our a value is 1. So 8 over 2. What is 8 over 2 equal to? So right now, you guys see anywhere on your paper where it says axis of symmetry? Right here, axis of symmetry. I want you guys to write for that. Write x equals 4. That's your axis of symmetry. Once you've written x equals 4 as your axis of symmetry, what I'd like you to do on your graph, zoom out just a bit here. Okay? On your graph, I would like you to make a vertical line right where x is equal to 4. So right here, make a vertical line, draw in your axis of symmetry. Remember, this equation that we're working with right now is y equals x squared. Is it plus 8x or minus 8x? Minus 8x plus 15, right? Okay. And we already have the axis of symmetry. It's where x is equal to a 4. Oh, by the way, guys, what's our y-intercept going to be? Here's the end. See it right there? That's the constant at the end. The y-intercept will always be the number that's right there at the end every single time when it's in this form. So your y-intercept is going to be at a 0, 15. All right? By the way, what's the only thing else we need to find right here? The vertex. We know the vertex is going to be at 4. Now what we're going to do is we're going to use a calculator. We'll be able to figure out where the vertex actually is located. All right, my class is left me. We're going to go and finish this problem here. I'm going to clear this out. Type in x squared minus 8x plus 15. All right, and I'm going to check the table right here. All right. What we're going to do is we're going to fill in the table from 0 all the way to 8. So right now, I'm going to fill in 0, 1, 2, 3, 4, 5, 6, 7, and 8. And these are the corresponding y values for that. 0, 3, 8, and 15. Okay? So right now we're going to take this right here and we're going to actually graph these. We're going to go 0 and see here. Let's move this down a little bit. Plot 0, 15. Right there. There's 0, 15. Notice these are all counting up by 2s. 2, 4, 6, 8. Keeps going up to those 15 right there. We've got a 1 and an 8. There's 1, 8. 2, 3 will be right about here. 3, 0 is going to be right here. 4, negative 1, right here. Notice there's our vertex. All right, so we actually just found our vertex. It's at 4, negative 1. All right, and then here's a way to graph things. If you just kind of count how many spaces it is to the axis symmetry, it makes things a little bit faster. 2 spaces over, 2 spaces over. 1, 2, 3, 1, 2, 3. Here, there's 4 spaces. I'm just going to go 4 spaces. And then you don't have to worry about looking at your ordered pairs all the time. Just notice that this graph, this parabola, goes straight down through these points, curves through the vertex, and it curves going upward. There we go. So there's our parabola, all right? And you'll notice some symmetry within the y values, all right? So here's our vertex. I'm highlighting it, all right? Notice we have zeros on both sides of the negative 1. We have 3. Both have an 8 and a 15. So think about it this way. If you see a parabola, all right, in your ordered pairs, you see this symmetry, that lets you know the vertex is sitting there right in the middle. So that's how you can use a table as well to be able to interpret whether or not this is indeed your vertex. So hopefully you guys can be able to witness that. This problem is now totally done. Tomorrow we'll do other ways, more by hand and less by the graphing calculator. But this right here is a good way to solve for your y-intercept, your axis of symmetry, and your vertex. Y'all have a good day.